Let's kick it off with Unit 10, Exponential Functions. Our first lesson, 10.1, is our basic introduction to exponential functions. And again, our objective is students will be able to write and graph an exponential function given a set of data or its equation. Now, what is an exponential function? Exponential functions are those functions with exponents that are variable, and they're very important in math, science, and engineering. So all my engineers out there, this is very key in your job. Today, what we're going to do is we're going to explore the basic characteristic of the simplest exponential function. So this is as basic as it gets. So now the basic, as you can see, the basic exponential function is y equals to b to the x. Notice this x, the exponent is the variable, where b is greater than 1 and b is greater than 0 and b cannot be equal to 1. Now, consider the function y equals 2 of x, fill in the table without using your calculator, and then sketch your graph. Now, I want you to be able to understand, how do I plug this in? We're going to do the first one without our calculator, and then the second one we're going to do with the calculator. So just like you would in any function, wherever you see x, you're going to replace it with the number that they gave to you. So this first one's going to be 2 to the negative 3, and if you enter that on the calculator, you get 1 over 8. This becomes 2 to the negative 2, which is 1 over 4. 2 to the negative 1, which is a half. Then we have 2 to the 0, which is 1. 2 to the first, which is 2. 2 to the second is 4, and 2 to the third is 8. So all we're doing, wherever I see this x, it's in my exponent, I'm replacing it. Now, how do I go ahead and sketch this? So I know here is negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now let's plot the points. At negative 3, it is 1/8. So you know it's going to be somewhere really at the bottom. Negative 2 is a quarter. It's going to be a little bit over. At negative 1, it's a half, so it's definitely halfway there. At 0, it's 1. At 2, it's 2. And then here, 1, 2, 3, 4, 5, 6, 7, 8. 3, it's 8. So when you sketch this, and of course you're going to have a way better drawing than mine, you're going to sketch it like this with the arrows at the end, meaning this graph go on forever. This is what an exponential function looks like, y of 2 of x. And that's it without using the calculator. Now, let's move on to exercise 2. It says, consider the function y equals half x. Using your calculator, find a table and then sketch it. Now, what you're going to do is you're going to need your calculator. That means, yeah, you have to get up and get one. If you haven't done so, I am so sorry to make you get up again. I'll wait for you to get a calculator. Good. Now you got a calculator. Let's go to calculate. We're going to actually go to home, and I want to go to graph. And I'm going to enter my function. My function was, remember how to enter fraction, control division, 1 divided, 1 at the bottom is 2, come out, close my parentheses, and my x need to be in the exponent, so I have to press this little caret sign at the bottom of the equal sign and put x. You should have something that looks like this. Now that you have this exact function, you hit enter. You know this is what your graph should look like. Now let's fill in the table. How do you get the table? Remember, now we go to menu, we go to table, split screen. Now the question is asking me from negative 3, so I'm going to go up to negative 3, and these are my values. So on your paper, at negative 3 it's 8, at negative 2 is 4, 2, and these, and all I'm doing is I'm just copying these values from the table. That's 0.5, 0.25, and then 0.15. It's a lot easier than what we did up here where we substituted. Now the calculator does it for you. So I'm going to go ahead, -3, and I need to just, oops, I actually started one box earlier. -3, -2, -1, 0, 1, 2, 3. And I want to go ahead and plot these points. So it's a 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2. At 0, it's 1.5. A little bit down, and then all the way down. So your graph should look something like this. Now the question is, look at these graphs. So this is an increasing graph. Notice that the y values keep going up. And this is what we call a decreasing graph. And we're going to talk about this. This is called an exponential decay. And this is called an exponential growth, which we're going to talk about in our future lessons. Now, we're going to go to exercise 3. It says, based on your graph and behavior you saw in exercise 1 and 2, set a domain and range. And if you notice, guys, domain and range, this is something that has been popping up from unit 1. So looking at that, I need to find what's my domain and what's my range. So my domain, I know, of course, we all know this is my x and range is my y. What are my domain and what are my range? So domain, your x. Remember I said the arrows? Look at where these fall. They always go on for the x. So your domain will be from -infinity to +infinity. This is something that goes on and on and on. But look at your range. What happened with these graphs? It never crosses the y-axis. It gets closer and closer and closer, but it never intersects. So your y value will be everything from this point right here going up. And at that point, oops, practice problem, not as yet. At that point, it's going to be 0, comma, to +infinity. Okay, so the thing is, you need to remember your domain is going to be all real numbers, and your range, meaning an exponential function, is always going to be above the x-axis. Which of the following exponential function will increase as x increase? Now, this is one of those questions where I'm going to go and put that in my calculator. Which of the following exponential function would increase as x increase? So the first thing that I want to do is go to my calculator, clear all of this, and then I want to go back to graph. The first one says it needs to be, oops, not that one, I need to enter a fraction, control division, 2/3, and this needs to be to the x power. Now what I'm going to do is I'm going to go ahead and look at the table because I want to know which of the following, as x increases, which of the following exponential function would increase as x increase. So as x increase, look at these values, they keep going down. They keep getting closer to 0 as x increase. So you know that's not going to be the 1. So hit tab, you can go up, and then let's go back and change this to the second equation that we have. The second equation says it is 5 and make the bottom 4. Enter. Now look at this. When x is 4 is 2.4. When x is 5 is 3.05. When x is 6. Notice the number keeps going up, and that's exactly what this question is asking you for. Which of the following exponential function would increase as x increase? It will be choice number 2. And it says an exponential function will only increase if the base is greater than 1. If the base is greater than 1. Is 2/3 greater than 1? 2/3 greater than 1? No. Is 5 over 4 greater than 1? Yes. And again, 5 over 4 is same as 1 1/4. Now, remember the shortcut says an exponential function will increase if the base, if you want to write it, let's write it here. Exponential function will only increase when the base is greater than 1. And then, of course, it will decrease when it's between 0 and 1. Now, the last question I want to take into consideration is number 5. So we have this function here. The function says, now consider the function y equals 7 parentheses 3 to the x power. Determine the y-intercept of a function. And this is what we talked about, y-intercept. Your y-intercept is when x is equal to 0. So let's just really quickly substitute this. This becomes y equals 7 times 3 to the 0. This is 7 times 1. 3 to the 0 is 1. So your y-intercept is 7. So you know what 0, somewhere here, that's your y-intercept. Let's just call that 7. Does this exponential function increase or decrease? This one is actually what? It's increasing. Why? Because the base in this case is equal to 3, and 3 is greater than 1. Remember my base. So this is the function 7, 3 to the x. This is my base. What about the 7? We don't care about that 7. It's 3 to the x power. This is my base. Once that is greater than 1, it means it will automatically increase. And then the last one said, oh, let's just sketch a picture and label the y-intercept, which I actually somewhat did already. This is 7. That's our y-intercept, and it will just be a simple graph, and it doesn't have to be perfect. Some graph with arrows at the end passing through 7, and this should be labeled y equals 7, 3 to the x. There you go, very simple lesson guide. Everything can be done on the calculator. Now go ahead and do those practice problem, and good luck!